Hey, welcome back. This is week 2. We're going to talk about percentages and averages here for a second. There will be another video working through more problems, and then a third video involving or focusing on unit conversions, just reviewing some stuff. So if you go under week 2, under learning modules, you'll see that I've combined the files of notes, problems, and the assignment all into one so that you don't have to download multiple different things. If you click on this, it should take you over here to some PDF that looks like this. And we're going to work through this together because one of the most common ways that we compare data to try to make it meaningful in terms of change, in terms of, just overall comparison between different things, between things of the same nature that are moving one way or another over time, where we expected to be and where we actually versus where we actually ended up. One of the common tools we use for that is percentages, right? Our percentages. And so we want to take a minute to make sure we really understand them well, how they can be used both appropriately and inappropriately, and then get used to to using them on our own in the best way. So my first question is going to be looking actually ahead to what will happen in the next videos. It says, according to Metro Social Services from Nashville, the youth poverty rate went from 18.9% in 2012 to 17.8% in 2013. So I'm asking us to describe this change in two different ways, one that makes it look large and one that makes it look small. So one of the challenges here is that we don't have the actual number, right? We don't have the actual number of youths living in poverty. All right, some youths were 17 when in 2012, and they were 18 in 2013. So they moved out of poverty, while others were born into poverty, or perhaps entered or left poverty as a result of their socioeconomic status. So we want to be able to describe the change from year to year in different ways, all right, and talk about which one's more appropriate. So let's let that, among many other questions and many other uses, all the uses of percentages, help motivate our study of this. So I'm just going to come over here to my editable PDF, and I'm going to switch back and forth between this and one where I've made some comments already. So, for example, here we've got this version where I've written some notes on it. So the first item we're going to talk about is percentage points. Right? In other words, when we're discussing data, we're discussing change or difference in percentages. One of the common things that most common mistakes is that people confuse percentage points with percent change, something we'll talk about in a second. So percentage points is actually a difference in ratios. All right, and so what I mean is, so here we've got this 4 out of 10 is 40%. So say 4 out of 10 people exhibited some trait. Right? And 6 out of 10 people perhaps exhibited that trait in the next experiment. So we ran some experiment once for 40% of the people participating exhibited some quality, and then the next round 6 out of 10 right, exhibited that quality. So 40% to 60% is a 20 right jump of 20 percentage points. Okay. In other words, we're looking at these ratios, 4 out of 10 and 6 out of 10. We're just looking at the difference in what those ratios simplify to. One simplifies to 40% and one simplifies to 60%. Okay? In the same way as 7% compared to 13% is a difference of 6 percentage points. Okay? So I want to take a minute and really hammer this home, because this is sort of a jumping off point we really need to be careful with. So here I've got the 4 out of 10 and the 6 out of 10 again, and I say that the change difference is 20 percentage points, right? 40 and 60. Okay, and this is really useful when the total amounts change. In other words, when in one round maybe we have 10 people, in the other round maybe we have more than 10, maybe we have less. So let's look at this example here. All right, I say in 1980, all right, in 1980, 40% of the population smoked. Okay? In 1990, only 30% smoked. Okay? So a natural way that people commonly mess this up, percentages up, is they'll say there was a 10% decrease. Okay? So I'm going to write that out. Commonly, all right, people will say there is a 10% 10% decrease. But that's not quite right. In other words, that's not quite what's happening. A 10% decrease would mean that compared to the 1980 value, we dropped by 10% of that value. Well, we're actually comparing a percentage of the population, a ratio, right, to another ratio. Okay. So what this is here is right, a decrease of 10 percentage points. Okay. Percentages indicate ratios, not differences. So if we need to talk about differences, right, in the sense of, right, these percentages, one way to do it is to talk about percentage points. So let's continue this example down here. In 1980, 80 out of 200 people smoked. Let's say our total population at that time was 200. 80 of those people smoked. That would be 40%. That is a 40% ratio. Right? In 1990 now, 75 of our new population total of 250 smoked. All right, 75 out of 250 is 30% as a ratio. All right. However, right, so in terms of difference of ratios, right, we have a 10 percentage point change, a 10 percentage point. Okay, I'm gonna write that. So this is a 10 percentage point difference. Okay. All right. However, in terms of the difference of actual smokers down here, in terms of the difference of actual smokers, all right, it's a good looking circle right there. All right, and the difference of actual smokers, all right, we need a new tool. Okay, that word says tool, not fool. All right, we need a new tool in order to compare, all right, the difference in actual smokers, the number of actual smokers. We have a way to compare the ratios here, but if we want to really compare, all right, the number of actual smokers, we need a new tool. And so that new tool is going to be the next thing we look at, percent change, all right, percent change. And we use percent change typically when we are comparing an old value to a new value. So for example, in our smoking example I was just using, we had a 2012 total, right? Total, and we were comparing it to a 2013 total. All right, we'll learn how to spell one of these days. And so we want to compare, all right, an old value to a new value. Okay, so I'm going to start by just talking about the way we calculate percent change. Okay, so we first we take our old value and subtract off our new value. This is just the difference in our values. Right? The difference in our values. Okay, after that, we divide by, well, when we're looking at percentage, we need a ratio. In other words, we have some number compared to or related to another number, right? Here, 4 was related to 10. How much of 10, right, was 4? It's 40%. So we want to know, as a percent change, we want to know the difference compared to one of our numbers. Well, it makes sense for us to compare it to the old number. If we're changing, we're sort of using the old number as our base, and the new number, right, has some sort of change compared to that base. So we will divide by the old number, right, our old value, you could say. And then we will make it a percentage, because that will simply be a ratio in terms of, right, just the same way here, 4/10 is 0.4. This will be some sort of decimal. We want to make it into a percent, so we multiply by 100 in terms of 100% to make it a percentage. All right. That's one thing that kind of bothers me as a mathematician, is people typically leave off of, when they multiply by 100, they leave off the fact that that is 100 with the units as a percent. All right, and units might be not quite the right word, but when we multiply by 100, we're really sort of changing what we're talking about, in the sense of it's a percent now, all right, not just a strict numerical quantity or ratio. Well, okay, I don't really like that, but we'll be all right. So the way we can calculate that is we take the new value, that used to be an N, I had some trouble making it a W, you'll get over it. The new value minus the old value, again, that gives us a difference, and we divide by the old value. So we get this difference compared to some older value. All right, so here's an example. All right, there were 160 Smarties in a box yesterday, and today there are 116. The question is, what is the percent change of Smarties in our box? Okay, so we've got an old value and we've got a new value. All right, so I'd like you to pause and take a second and just bust out this computation. All right, you might even be able to see where we're going. So pause the video, find the percent change, and then come back and compare it to our one down here. A 3, a 2, a 1. I'm going to keep going. So if you didn't pause it, hopefully you figured it out. Pause it and come back. So we got this negative number, right? Before you multiply by 100, it's negative 0.275, all right? And then once you multiply 100, it's obviously negative 27.5%, okay? So our percent change, that means that we lost, right, 27.5% of our original, right, 160 Smarties, right? That makes sense that we should compare, right, how much the change is to the old value. Now you see this negative sign here, right? There's a reason we picked new minus old up here, right? That negative sign right there indicates where the change, which direction the change happened. If the difference is negative, if the new value, right, is smaller than the old value, as in this case, right, then we'll have a negative percent change. If the new value is bigger, if we increased, then it'll be a positive percent change. Okay? So we've got percentage points and percent change. These things are really different, right? One's a difference in ratios, the percentage points, all right? And one is comparing an old value to a new value, all right? And looking at the percent change between those values. All right. Now those values could be percentages. They could be number of tigers in a zoo. They could be number of times Brad has been arrested for speeding. Right. There are different ways. All right. Different values we can compare. All right. Whereas with percentage points, we're looking strictly at differences in ratios. So now we're going to move on to the third type of percent really that we're going to look at here. And we're going to look at the remaining ones, the next two, a little less than the first two. All right, simply because commonly the first two take place more often. However, percent error is something I see a lot reading scientific articles and that sort of stuff. And so the more you're involved with chemistry, biology, that sort of stuff, or lab science, the more you might see a percent error. So here, we're going to look at when we have percent error, right? We're going to think of this as when we are comparing, arises when we compare an approximate value to an exact value. An approximate value to an exact value, okay? So what we're thinking is what we're gonna do is we're going to we'll just talk about how to calculate it first, and then we'll get into the nitty-gritty. We're going to find the error involved. All right. We're going to divide the error by an exact value. All right, and we're going to make a percentage. Okay. So let's walk through that moment by moment. If we're comparing an approximate value to an exact value, finding the error, right, is just going to be what? Take a second. Really think about it. Feel free to pause it. Finding the error is going to be what? Well, it's going to be the difference between our approximate value and our exact value, right? How far off are you from the exact value? What's the difference between those two measurements? Okay. Well, what we tend to do in mathematics is we tend to take the absolute value of these. So you might have seen absolute value with, right, bars around it like that, or you sometimes, if you're in computer programming, you just have abs and then ... that stuff in there. All right, but what that is it's just taking whatever that number is and taking its positive counterpart. So it's distance from zero, for example. Okay, and so the reason we do that is typically we care about percent error, and we then sort of talking about either direction comes later. All right, in other words, are your error above or below? All right, and that sort of thing. But so we find our error, which is just the difference from our approximation and the exact value. All right, we then divide the error by the exact value down here. Why would we divide by the exact value? Take a second and think about that. Go ahead and pause. I'll just be here. humming to myself. Do, 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 do. All right. We divide the error by the exact value because we want to compare how far off we were from the exact value to that exact value. As a percent of the value that is true, that is exact, how far away were we, right? Right? If the exact value is 1,000 and you were 2 units away, that's a very small percent of the exact value. However, if the exact value was 6 and you were 2 units away, that's a much bigger percent of the exact value. And we care about that. All right. So let's come down to an example. We estimated 70 people would turn up to a concert, but in fact 80 people did. We want to know the percent error in our approximation. What was the percent error here? Right? Whenever we're modeling things, we often care about percentage error. I'll take a second and see if you can work through this together. So here's the sort of shorthand of our formula. Right, so go ahead and pause it. 3, 2, 1. I'm going to keep going. All right. So hopefully you got something like 12.5%. Not like it, exactly it. Right? And so the way we would get that is we would say, all right, we need to take the exact absolute value of, well, we could do 70, not times, minus 80. What is that giving us again? That's giving us, right, how far away we were from the exact value. It's giving us our error. And then we're going to divide it with this fancy line like here, because PDF Expert doesn't have a math writing thing. And we're going to compare it to, what are we going to divide it by? 70 or 80? Well, 80, right? Because we want to know how far off were we compared to, this is looking good, all right, compared to, right, the actual, right, exact value, what really happened. Well, so then we get this down here, we get this all is equal to 10 over 80, right? Or simplifies to 1/8 or 0.125. All right. So we were 12.5% of the exact value away with our approximation. That's an important thing to know, right? 12.5% off, depending on what you're talking about, can be quite significant, right? It's a lot bigger than if we measured, let's say, 5.5% off or 2.5% off. Right? Those numbers are much smaller, and we want to be able to know how, not only how to calculate them, but what they mean, right, when we use them. All right, number 4, percent difference. All right, when both values mean the same kind of thing, this is where we're going to be using percent difference. So that's a little different than back up here with percent change. Right? Percent change was when comparing an old value to a new value. Percent difference is when both our values mean the same kind of thing. So for example, comparing the heights of 2 people. Right? Comparing the heights of 2 people. There isn't an old value or a new value necessarily if we compare Ashley's height to Brad's height. Right? But all right, we still want to be able to compare them and relate them in a meaningful way. So the way we do this, or a way to not paraphrase this, is to talk about it, is this is just taking the difference between 2 values and dividing by the average of those 2 values. Right? So how we're going to calculate that, breaking that down, is we're finding the difference between 2 values. So I'm going to call our values V1 and V2. So I might say V1 minus V2. All right. We typically take the absolute value of those 2 things. All right, because if we're talking about percent difference between 2 values, it doesn't make sense to say, well, Brad's should be the starting value instead of Ashley's, or Ashley's should be the starting value instead of Brad's, right? Because the values mean the same kind of thing, but they aren't applied to the same person, right? In other words, what's happening, for example, the U.S.'s total, if we're doing percent difference in the U.S.'s total of carbon emissions, let's say, all right, it doesn't make sense to do percent change of the U.S.'s total to Germany's total. But it would make sense to look at percent difference. Okay? And so saying which one, in other words, we use absolute values to remove the idea of, well, change from one to another in that sort of sense. So we find the difference, right, which is just the absolute value of the difference of those 2 values. And then we also find the average, right, because we're going to divide the difference by the average. Right? It doesn't make sense to necessarily take the difference between Brad's height and Ashley's height and divide by Brad's height. Right? Nor does it necessarily make sense to divide by Ashley's height, because again, we're not talking about a change of Ashley's height or a change of Brad's height. So what we do is we'll divide by the average of their two heights to see this percent difference between them. So the average of two numbers, hopefully we remember, is just you take them, add them together, and then what are you going to do? All at once, excellent, you divide by however many items you have. So in this case, we have 2 items that we're adding together, and we're going to divide by 2. So we found the difference, and then we found the average, and then we divide the difference by the average, and obviously later we got to make it a percent. So over here, we've got this. We've got V1 minus V2. Again, I've got absolute values here. There should just be 1 bar there. I just had troubles writing them. As you can see, handwriting is a course I passed with flying colors in 2nd grade. Not. All right, we divide then by the average here, and we can multiply by 100% to make this a percent. So this here is how we compute percent difference. So let's look at our example. Oh, Brad shows up again. I'm a little vain, apparently. Brad sold 15 tickets and Richard sold 25. All right, there's no need for that comma there, and it's going to bother me. All right, find the percentage difference between the number of tickets they sold. Well, first, we would want to find the difference here, right? So 15 minus 25, or 25 minus 15, once you take the absolute value, those are the same thing, and that's going to be 10, right? And then we're going to take 10, and we're going to divide it by, I'm just removing that X, it's going to make things harder. We're going to divide the difference by the average of 15 and 10, right? The average of 15 and 10. I'm sorry, 15 and 25. That's all right. We find the average between 15 and 25, all right, which is 20, right? Add 15 to 25 and you get 40. Divide by 2, you get 20. So we've got 10 over 20, all right? As a decimal, that is 0.5, right? 1/2. So it's equal to 0.5, and so we would say we've got a 50% difference between those two values, right? And it makes some sense then. 15 and 25, they're 10 away. Well, all right, there's a 50% difference between them in the sense of compared to their average, right? 10, the difference between them compared to their average is half of that average, right? So we're going to see that one even a little less, but I include it because it shows up quite a bit in certain, typically in some New York Times articles I've seen. Right. So we've got one last thing. I know we're running on fumes, but we've got one last thing to look at, and it's the difference between mean and weighted mean. And I want to take a second and just look at this, and then we're going to go through some problems in the next video, and hopefully that'll clear up any sort of issues that you've got going. So the mean of a data set, or oftentimes what we call one of our tools, our measures of center, often called an average, is where if we've got n data points, so like x1, x2, all the way up to xn, right? These might be, 7, 6, 29, so on and so forth. They could be, numbers representing anything, right? But if we've got these n items, these n values, the mean, right, often denoted with a bar over that x, all right, is just adding them all up and dividing by how many you have, right? The reason I wanted to include this here is because of this symbol here, right? The symbols going on in this thing right here, right? This thing is equal to what we call the summation, all right, where I goes from 1 to n of xi, all divided by n. So this symbol right here, the summation sign, which is a Greek capital sigma, all right, is just where you start where I is equal to 1, so x sub 1, and then you add, because of this thing, between the next term, which is I goes from 1 to 2 to 3 to 4, all the way up to n. So x sub 1 plus x sub 2 plus x sub 3, all the way up to x sub n. All of that divided by n. So these two lines really, mathematically, are the same thing, represent the same thing. So that's the mean. That's something we've had before, we've dealt with before. All right. Now, the next thing I'm going to look at is the weighted mean. All right. A weighted mean, where here each value takes on a different weight. All right. Each value takes on a different weight. Okay? And so you've actually seen this type of thing before, all right, in grades, all right, in averaging large data sets, all right. Oftentimes what's happening here is we might have certain values again, all right. Let's say we have n values, and each of those values is worth a certain weight, all right. So this omega or W1 corresponds to X1. That's the weight for X1, okay, and likewise with omega 2, W2, and X2. Right? So this weighted mean is where we take each of our values and multiply them by their corresponding weights, right here. We sum them all up, right, and then we divide by the sum of the weights. Okay? So go ahead and replay that. I won't just re-say it all, but that is how we get a weighted mean, how we use compute weighted means. And here is this written in our summation notation we learned over here. This is what we call summation notation. Summation notation. All right. So let's quickly think of an example where we've seen weighted means. And I'm going to focus in on grades because you're actually seeing it in our course too. Have you ever seen something, had a class where it had a breakdown of, well, something in your grade was worth 50% of your grade, something else was worth 10%, another thing was worth 20%, that puts us at 80, so then one other thing was worth 5%, and then another thing was worth 15%. Hopefully, not a great numbers guy, that's a joke, that adds up to 100, right? So let's say over here, right, in this 50% category, all right, you got really 80% of the points, right? And then in the 10% category, you got 85% of the points, and over here you got 90% of the points. Here you got 100% of the points, and here you got 90% of the points again. Okay. Well, the question is, what's your final grade? What's the final average, right, throughout your course for your grade? Well, what we do is you take this 80% has a weight of 50 or 0.5, we would often say. Okay, so I'm going to come over here and I would say, all right, well then we'd have is equal to 80 times 0.5 representing the 50% of your grade plus, all right, then 85 times, all right, well, 10% of our grade, let's call it 0.1, plus let's see, 90% was worth 20% of your grade, and then plus, ooh, you got 100% on, well, that's only 5% of your grade, and then you got 90% again, or 90 of the points on times 0.15. All right, so I'm going to go back through and I'm going to put in parentheses all the items that are our weights, right? And I'm going to ask you to note what our weights all add up to. Well, they add up to 1. Or 100% of your total grade, right? That's one of the nicest ways you've seen weighted means used before. We're going to see them used in other ways where the weights don't necessarily add up to 1, all right? But if you computed this, all right, and then you divided it all, right, divided it all by the sum of the weights, which is 1, you would get your overall grade, right? So we're going to take a minute, we're going to pause, I'm going to give you a moment to work through, make sure you've got all these ideas down, and then we are going to jump into problems in the next video. All right, so I'll see you when I see you.